If you rejoin the group, you come back to this stage. And in terms of the usage control model, we are really doing attribute-based access control here. And we are changing these attributes. That is the crucial thing. The enroll operation actually changes the attributes. The disenroll, it changes the attributes. And, we can come up with a similar sort of... we are really trying to model this state diagram using these attributes, if you will. Now, the only operation I'm going to show you, sort of stated in the Yukon model, is the document read. And I'm not going to show you the enroll, disenroll, and the add, remove, because we really don't have time for that. But here is the flavor of what the usage control model can do for you. It's saying, okay, here is a subject who's trying to read this object. Okay, that's the operation that is being attempted. And whether this operation is allowed is going to be determined by attributes of the subject and object. And the attributes I'm going to check are that, well, your membership status in the group is defined. It can't be null. All right? So you are either in state 2 or state 3. The membership attribute of the document is also defined. It can't be null. Okay? So either the user is a member of the group or not, or the document is a member of the group or not. And then the timestamp, and so you can sort of read these yourself. I don't have to walk through them. But basically, your membership status has to be defined and your joint timestamps have to be defined. Okay? Both the member and the document have to be enrolled into the group. And then it's possible that you left the group, or it's possible that you're still a member of the group. And then there are different conditions that need to be checked on the relative values of these timestamps, depending on the particular policy that we are enforcing. So if the policy says you can only read the document if it was made available to the group after you're joining, that's what this part is testing. And this part here is saying that, look, after you've left the group, you still retain access to documents that were available to the group during your access. Now, of course, if you change the policy, these predicates will change. But, we have a well-defined place to put them. And then we need an ongoing authorization check. So this is one aspect of usage control. You don't do the checking just at the beginning. You also continue to do it during the access. And we need an ongoing authorization check so that if the document is removed from the group, then this condition is basically access is turned off. If I remove the document from the group, access is terminated. If I remove the user from the group, I don't need to terminate the access because this document continues to be accessible because it was created during the period of membership. All right? So you can convince yourself that this policy is correctly stated or not, but the point is that we have the machinery to state the policy of pre-authorization before you start the access, and then ongoing authorization while the access is continuing. The usage control model is designed to handle that. Now, when we move to the enforcement model, our biggest task is to figure out how to approximate this ideal of instant revocation and preemptive revocation. Okay? And in order to do that, we are going to present two models. One model is actually not going to allow you any offline access and is going to enforce instant revocation and preemptive revocation as closely as feasible. I will show you the specification for that. And then that's not a really practical model. And then the second model is going to show how to do an approximation. So again, I'm not going to show you the enroll, disenroll, and so on. The main point I want to make with respect to this slide is that we have this notion of a member attribute, a joint timestamp, a leave timestamp, and these attributes are available to us on the client machine, but those are not the authoritative values of these attributes. They are like locally cached values. The authoritative values of the member attribute, join timestamp, and leave timestamp are available on some server somewhere. Okay, so because that's the only place where they can be maintained, since I can't reach out to every laptop in the world and actually try to update the attributes there. All right, the authoritative values are maintained on a server, and local cache values are available on the client, but the enforcement is done with respect to the client. Okay, the values on the client. So if I want to do a faithful enforcement, before I check these attributes, I have to make sure I have the most up-to-date value. So I have to go out and refresh my cache. All right? And not only do I have to do that at the beginning, while access is going on, I have to continuously do that. Now, what does it mean, continuously do that? Do I do it every machine cycle? Do I do it, if you think about it as a practical matter, and there's a network latency delay, so I'm always a little bit out of date, right? I'm never going to be 100% up to date. That's intrinsic to distributed systems. So we are not going to try and, we're just going to sort of ignore that problem and say, in the model, we're going to say you do it continuously, all right? All right? So with the understanding, we realize that in practice, when you implement this, you can only approximate it. So the faithful solution I'll show you is basically the main difference with respect to this policy statement is that you need to update these values before you do this checking. In Yukon terminology, the requirement to update these values before doing the checking is called an obligation. And it's called a pre-obligation because you have to do it before the access is granted. And you can do that only if there is connectivity. If there is no connectivity, you're not able to do that. So you require the system to be in a state where you can actually complete that update and refresh. Okay? So the requirement that there be connectivity is called a condition in usage control model. The requirement that you do the update is called an obligation. And both of these are needed in order to implement the faithful model. And you need that not only for pre-authorization, you need it during ongoing authorization also. So that's the sort of point that we need the power of usage control. We need the full power of usage control to be able to enforce this. Even the policy looks very simple, but we need the sophistication of the Yukon model to enforce it. The simple-minded access control model is not, access matrix model is not enough for this purpose. Now, when you're doing an approximation, basically, you cannot afford to update, to refresh your cache every time. Okay, as a practical matter, that's not reasonable. And yes, the bigger the window of refresh, the less accurate the enforcement of your policy, the bigger your approximation. Okay, so really, you need to sort of update not every time, but every so often. Okay, so maybe every 10 times, maybe every 20 times you need to go do an update. And if you're doing an update, let's say every 20 times, every time you do an access, there has to be some countdown. Okay, so all of that is required in order to, all of that machinery is required in order to enforce the approximate model. So really, all we have done is to enforce the faithful model, we have to sort of do this refreshing continuously. But to enforce the approximate model, we have to do it periodically, and we have to have some criteria for how frequently to do it. And, again, it takes the full machinery of the Yukon model to be able to state this. And that's really part of